The RAS protein is a representative example of the large family of GTPases that function as molecular switches. The nucleotide binding site of RAS is formed by several conserved protein loops that cluster at one end of the protein. In its inactive state, RAS is bound tightly to GDP. As a molecular switch, RAS can toggle between two conformational states, depending on whether GDP or GTP is bound. Two regions, called switch 1 and switch 2, change conformation dramatically. The change in conformational state allows other proteins to distinguish active RAS from inactive RAS. Active GTP-bound RAS binds to and activates downstream target proteins in the cell signaling pathways. A space-filling model shows that the conformational changes between the GDP and GTP-bound forms of RAS spread over the whole surface of the protein. The two switch regions move the most. RAS hydrolyzes GTP to switch off, that is, to convert from the GTP-bound state to the GDP-bound state. This hydrolysis reaction requires the action of a RAS GTPase activating protein, or RAS-GAP for short. RAS-GAP binds tightly to RAS, burying the bound GTP. It inserts an arginine side chain directly into the active site. The arginine, together with threonine and glutamine side chains of RAS itself, promote the hydrolysis of GTP.